Yes, again, for the sake of informing the new recording, in the morning we are going to be looking at the problems you might be facing, the difficulties that you're having about the data processing phase, and then running the algorithms. And afterwards, after a couple of breaks, we're going to be introducing how you can classify your data, and how afterwards how you can get some new information from your data and contribute to the knowledge of the whole domain. So there will be an introduction of an application that you can run online, and then the alternative version in Colab. So yesterday we were talking among us when Khan has shown that he was working in the environment of Visions of Chaos online. I mentioned that there are numerous applications that you can use online that are very valuable, and they keep growing and growing, and they are actually they have in the background, they have these algorithms that we're working on in this workshop. So you may always choose to use those applications that might more or less give similar results. But in terms of understanding the processes and controlling them and changing and manipulating them, you need to get the understanding of those algorithms, how they work, right? What means what? You don't have to be a coder, you don't have to be a developer, but when you're code literate, you can have access to that skill that you can create your own models in machine learning, right? So that's what we're trying to introduce actually while showing the app version of these algorithms. And you're going to be seeing that in terms of classification. So without further ado, let's hear from Tao, who already has some experience to share. Tao?
Yeah, I'm here.
Hi, Tao.
Hi.
So let's hear from you if you would like to share how it went and the results.
The results here, I not finished the running, but it gets some results here. And the results is about I think the change is not very strong, and it's quite similar at the original image here. Maybe I think it's about the wave sequence, the waves to this image. It's not very the you know what mean what I means. Yeah.
How did you ever try to generate the process without any spectrogram that is included in your training set from outside?
Actually, these are just training epoch results. So the algorithm just try to generate the original image from the spectrogram. So these have to be similar. But you can try your model from
Yes.
the below code cell, like translating new spectrogram files. You see that, right? If you run that, you just can you run the libraries?
On the libraries here.
No, just down.
Okay.
Yeah.
Just continue, right?
Yeah, and from here,
Okay.
you have
I have music now.
you should change your model. Like,
Mm-hmm.
yeah, where was your result?
Yes. The data sets.
The models. Your
ultimate.
model.
I need to here. Yeah, the models here.
And the
Right.
models,
It's
the
here.
6,001, yeah.
Yeah.
Just paste them,
Yeah. Right.
yeah, and just run it. Now it will give you
But
what
you
again?
need to specify the folder that you are taking for.
Okay.
Yeah, just the file, not the folder.
Right.
Give it
You
a
might
file.
even use one of our images to try out in a different data set, but I suppose you have multiple files in that cluster.
Okay. This is a PNG.
Okay,
Okay.
perfect.
PNG, and here, let me try to change. Right?
Yeah, okay. Now run.
Okay, this.
What give?
I need to move some of this one. Alternative. I have alternative. Let me see.
Just select the file from alternative spectrograms.
Okay.
Just copy the file, yeah. Okay.
Right?
Yeah, you see, now this is that.
Yeah.
New.
Oh, a new one. Yeah.
Yeah.
Okay. So I
This
can.
isn't in your training set, right?
Right. Yeah, absolutely. Sorry, I want to give some difference result. And let me paste the code. I give this one. Maybe it should different. I think it can be show
So,
different results.
When you select the earlier models, the results will little bit faded from the original one.
Yeah. Okay.
But both are good results, I think.
Okay. Okay. I think I did. Right.
And these are not in your training set, right? The spectrogram files.
My training, it's my training here, right? Because I use all the data I set in here is okay. I know what you mean. I think should be changed.
No. It will not work. It's not a spectrogram file, but did you use that like John Cage, Walter Wolke PNG in your training?
Yeah.
So this is why it gives you the very good results. If you just try a very new spectrogram, it does not include it in your training, it will give you some new results.
Okay.
But these results are saying that your model works. And if you just give the data from training set, it generates a building.
Maybe we can try like that one. If we just choose one of the spectrograms that included in our data set, whether like the music genre is totally different, it might create a different version of it. So how can you go by the main file that we shared with you, like the data set file? Can you access it right now?
This one?
Yeah, this one. You might click on the music.
Okay.
Then spectrograms or resize one. Please use the resize one. Yeah. Maybe taking one picture. You can just download one of them.
Okay, I know.
and at this one, so see the different results with the different kind of a music. It would be interesting, I suppose.
Okay, just to take copy one
Okay.
to my dataset. Just oh, maybe I need to download it.
Yeah,
and
you had
upload.
to download it most probably.
Hold on, please. And change it to mine. This one.
Yeah.
And get this one.
Yeah, this one.
And run my my training.
Yeah,
your
your
model,
training,
yeah.
training,
Right.
yeah.
Yeah.
The machine doesn't know how to read that music song, but it generates a total different image because it learns how to translate the audio spectrogram to image rather than like a style of music. So different results can be achieved by trying different genres of songs. As well
Let
as
me
like,
try another one, maybe.
okay, but the results right now it's a little bit blurry and a little bit abstracted. And I'm talking for all the participants. We have the same results almost. Better you train your model with your more images and more like high resolution images. And the
Yeah.
future, it would get better and better in terms of image quality and abstract representations in terms of a building facade or like a 3D image. It would get better, but the initial outcomes are, the expected outcomes are this one. So I want to congratulate you. This is a really like perfect work in progress.
Oh, thank you, thank you. I just try after the workshop. I will try that better. I think it will be get some amazing results.
This is like a kind of an experimentation. You can run the model, whatever data you want like to. But in terms of like you have just learned how to convert the musical data into an image. So I think that's the most crucial part of our workshop.
Okay. Where are you? Yes. Let me see.
These models you are trying, like the earliest models of the training set, so the results will, let's say,
Not very stable.
yeah, getting worse. But
yeah,
if you try just the latest model, like the model 6000 H5, it is your last training.
Yes.
Last training model, so it will give you better results according to earliest models.
Okay, I think
One
it should.
option. Sorry.
Sorry.
Please go.
Maybe it's not enough steps. I think it should be around more
Yeah,
time.
I think the data is very small. Like it
Yes.
needs a lot more data.
Okay.
By the
If
way,
you can just gather 500, 600 images, it will give you better results.
Okay. Okay. Just increase the revolutions.
and
based
how
on the
many images that your data set includes?
It's 120.
120. Like it's a little bit small data set. If you increase it, it would get much more better because we train our machine with like 550 images or so.
Oh, okay. Okay.
But as I assume your resolutions were quite high, that's
Mhm.
why the model works well.
Mhm.
One technique that you can implement your model is increasing the epoch number, which will just take much more time to train the model, but the results will get better as the model just learns to how to implement it correctly more than the like 6,000 epoch number. So if you increase it and if you have the Colab Pro, it wouldn't cost you so much time actually. Maybe you can
Okay.
try to increase the epoch time, train the model again, and compare the results with the initial model and the implemented model to increase epoch time.
Okay. Okay. And one more questions. I found my data is about the original image. I think you can see here. This is the resize image, and this is the original image. They are the same number as pictures. The
Yeah,
same number match the pictures, right?
Yeah. It will be same number.
Yeah.
But if I make the training, I think it's in the training, right? The image is the number, you can 1 it's changed.
No, the name can be changed. Yeah, it just selects from file randomly. But
Okay, it's random, right?
Yeah.
Random seed.
yeah,
It's making
Okay.
pairs in that section. That's why the numbers are changing. It depends
So
also the number of the files, audio spectrograms in your file. It
Yeah.
should be equal in the theory, but if it's not, so it takes the minimum number of which one you have.
okay, I know. So I'm the machine makes the choice, and I need to pick the result, which result pick the frame, which frame I need in the result. Is
sorry,
that
what? Sorry,
right?
sorry.
That means the code here,
Mhm.
it make the random seed and for calculations, and I need to pick it individually by myself. I means from the result. Maybe this one I would like to see this one, the
Mhm.
7i result. But I means the result is randomly, so I need to find it in the result part, right?
Oh yeah. In the code, can you just go back to code, the
Okay.
notebook? Okay, so for a little bit up,
Mhm.
a little bit. Yeah, in here, the load dataset part, the three image generated, you see source generated, expected. Yeah, this part. When you run that, it just selects randomly from your training set, and it tries it again to generate the expected result. So when you run it randomly, it will just
Yeah.
select randomly from your training set to generate an image, generate the
Okay.
expected image. For your if you want to just like pair the spectrograms and architectures like by specifically these
Yeah.
spectrograms I want to belong to this architectural image, you can do it manually, or you can just look into it when in the pairing part there's this if loop, and it just says that for the length of the like spectrogram folder, just pair them randomly. But you can just write a 2-line code, I think, to select the specific spectrograms for specific architectural images, to pair them.
Okay, I know what you mean. Yeah. I got it.
But
Yeah.
Oh, okay. I was gonna ask, Tao, do you know why we need more data to for the model to become more successful?
Yeah, I think I know because the machine, I mean the AI machine, it needs more like materials to analyze and for fit the originals, fit the real image. I think more images. I think it's better for learning to for fit it to fit the result well. That's what I mean. Yeah.
Yeah. Okay. Because we didn't touch upon that type of information, but maybe for other attendees too, I may just shortly show you guys the neural networks.
Mhm.
I'm
Okay.
sure most of you. Okay, I think
So
okay.
should I?
Can
Yeah.
you
Okay.
can you see it right now?
Yeah.
Okay, so basically these artificial neural networks are as such, and there's the input layer and the output layer, and these layers, they can be several, and you see these weights right here, and these are the weights for the features that we have in our data, right? The properties, the features, etc., of that input data. And the latent space we keep talking about is actually here, and it says hidden layer, and there are several of them, and it spills out the output here. So in this logic, we see later the deep neural networks, and the back propagation that Yann LeCun had come up with adds to these neural networks the back propagation, and that those weights that we just saw here, the machine starts learning which weight is important. I mean, which feature is important and which feature is more important to take into consideration. And that becomes the weight of these features. So in the next time when getting this input, when processing it, it gives more weight to that feature, and the output becomes refined. Right, so that refinement here, and that's probably what you say by saying fitting, and that is the activation function that you mentioned, most probably, and these get more refined by more data. That's why we need more data to get the model produce more successful results. But there are some ways to produce more data from the data that we have, that's called creating synthetic data. And there are ways to do that if you don't have enough sources to find data. You can create some and add to your data set. Yeah, that's what I wanted to mention for those who don't have access to that knowledge. So you can see that back propagation here too. So as the input is processed here, it gives out an loss value, and then the cost function here gives that information to the model in terms of the weights here, and then it's reiterated. Okay.
Okay, I understand now.
Okay, I hope it helped. Yes, so Tao, do you have any other questions so far? And if not others, do we have others who have any questions, who have experienced the model, the processes of the model, who are having any problems? So we're not calling out names as if we're in classroom. But if you have questions, or if you're struggling right now with anything, any kind of information, let us know. Otherwise, we're gonna move on to the classification application after a short break.
I have one more questions.
Sure.
If I can pick the music with GIS, I can if I can recognize the music, which site it is. It's longitude, it's latitude. How can I match the GIS music to my to match my buildings in that place?
Are you asking what pixel location your music?
Yeah, the
Yeah.
location can match my buildings.
When you are pairing the images, right? Spectrogram
Right.
images and architectural images.
Yeah.
You are asking which part is the spectrogram image and which part is architectural.
I mean, you know, the Google Map has street views, and
Yeah.
I can pick my location there,
Yeah.
and I can record the music there. So how can I match this site, the architecture images, just at the same site?
I think
Oh.
Sal's question is much more related that the future task of ours that we are trying to do right now. The question is just like an interesting one, and we are thinking about it to make a mappification, something like that, like to match the music sources with the generated images in that their vernacular style. So we are thinking to implement GIS methods for retrieving both the data in terms of the vernacular architectural instances and with the musical archive. But right now, I can't offer you a direct code or something like that. It's like a little bit working on progress. But if we have the immediate results after the future workshop, we will be sharing on both Discord. In terms of you're asking for a code for it or a paper for it, we will hopefully provide that because we are currently working on that. So we are trying to reach one musician in Turkey who has a history of like the Asian architectural and not Asian architecture, Asian music history in terms of like the temporal locations and in terms of like the regions which the folk music are based upon. And at the end, our main outcome or expected outcome is to just implement the generated outcomes as the architectural images from the machine learning process and map it onto the real locations with using GIS or other methods. So I think you're kind of searching something similar to that, right?
Yes.
So, but
Yeah.
currently we don't have like a code at the hand yet, but we would like to be happy to share with you when we have it.
Okay, thank you very much. And I totally in favor for your ideas for this local intelligence projects based on the music. Maybe it can, and I will try it because I can't. It's really hard for combine the GIS data for me. Beyond it's beyond my abilities. Yeah.
Yeah, the data like science is like a complete broad world. It includes the GIS methods, it includes data scraping methods, it includes data machine learning methods. So it's a broad team. No one is just has to be expert on each team. That's where we are working as a team. So one of the initial aims of like starting this workshop series is to establish a network with the people who are interested in that kind of data sciences, that kind of localness is introduced. That's the primary aim of the workshop actually. So we would like to be like be contact with you for the first future studies as well. We can always like contact with us in Discord channel. We can always email to us as on like IQ of the lab. So I'm happy that one of our students are just interested in that current team. So we would like to share with you the more information when we got it.
Thank you. Just get in touch. Yeah.
Naila Hocam, do you want to add something in terms of like the specification, because you're like
definitely that's how you just commented.
okay.
Yeah.
So do we have one more volunteer to show their work in terms of like the output maybe, or any current problem that you have just encountered during training the models, or maybe just plotting the output with the code?
Hi, I have a question.
Yes.
I experiment the code and everything was fine, and the code excited me. I'm so happy I'm here and trying this code. And my question is, actually, if we want to add data to the data set, do we have to add music to the image randomly for that pair images? For example, in my country, music is closely related to places. For example, for Esfahan, we have Gushe Esfahan. It's the name of local music for there. And classification can be placed as a photo of a place and local music in the same place for that pairs. I want to know if I want add data, I should add music for that pair randomly, or I can classification like that I said to you.
As Mustafa has just mentioned, if you implement the code to specify pairing system, because right now the pairing works randomly, as we just said, but it needs a little bit like a couple of more code into that to pair the images to Isfahan music to Isfahan one. But it would make sense if you just provide more data in terms of like these classes, not maybe just Isfahan, but other cities like Tehran. You can just classify lots of images from that on. And if you have like more classes, and each class has to have like a more than like maybe 50 examples, that would make the model work better, as I assume. Maybe Mustafa has something
You
to
can, I think for automation of the pairing part, we will just provide it, and you can just find it on line 2. Like there's a 2 line of 3 lines code to select the specific files to pair. But in manual, it will become much easier to just create different folders, like Esfahan folder, Ankara folder, etc., etc., etc. If you just define different folders for architectural images and music files, you can pair the folders inside that. By this, you can pair just like Isfahan music to Isfahan buildings and different city music to different city buildings. If you can just create different folders for images, when you pair them, it will just pair the location based. It will just do location based pairings. It will become much easier.
Arife,
Yes.
do you have the material? Do you want to share your screen and maybe ask where you do what?
I'm now with an other laptop. I'm not in my own laptop, but I'm so happy. This process gave me great idea. I will share my idea with you as soon as possible.
Okay, anytime.
Thank you. Thank you.
So who else wants to share with the process information or the generated output with us?
I think we never got to meet Ellen. Ellen, are you there? Do you mind introducing yourself? I think you couldn't attend earlier. Could you? Okay. Silence is gold. So before moving on with classification, maybe we can give a short break, like 5 minutes, and yeah, start in 5 minutes, huh? I'm not saying like 10:50 because we have different time zones, but in 10 minutes, in 5 minutes, we can start, I guess. Selen Hocam, Mustafa Hocam.
Yeah, okay.
Okay.
Hi, everyone. Everyone is back?
Yeah.
Okay. So right now we will begin the data classification in terms of understanding how does machine understands the locality. As you all know, we have worked and contributed our data sets from various cities from the Aegean zone. It includes the Turkish cities, the Greek cities, some Bulgarian cities, and so on and so forth. As well as some architectural features show some similarity in terms of like the building facades, the exteriors, but at the end, it has some like stylistic differences due to the different geographical regions. And right now we are trying to explore that if the machine can read it and learn how to differentiate different architectural images in terms of their labels, which is given as the cities. So for that purposes, there are a couple of tools that you can follow. The first classification methods are generally run by the code in Python or JavaScript in terms of the machine learning processes, but they're a little bit more complicated using different libraries in terms of TensorFlow, Keras libraries, etc. But there are also like the tools that have a user interface that you can directly provide your data into and directly generate a class in a software environment. Then therefore train your methods in that user environment and have the direct output in a visual manner. So we will both see our experimentation in terms of data classification of the architectural instances. And after that, we will introduce you how to use the tool, and we will expect you to also try that data classification part with your data sets that you have collected this far. So I'm sharing my screen. This is the tool.
Selen Hocam, just a second. Your monitor is shaking, so yeah, you may want to get it more stable.
Okay, sorry.
Okay.
Do you see me right now clearly? Unfortunately, I'm just making it. Okay, so we will use the Teachable Machine, which is the Google-based platform. As you can see here, I just open a new tab for complete news. So you can just easily go by Get Started and choose different type of project sets. Our experimentation will be based on the image project to classify the images that we have just collected in terms of architectural instances from different Asian cities. So I'm choosing the image project, but you can also try with your audio set as well. So I will use the standard image model. And here the interface gives me the option to add the class. What are the classes? To introduce it firstly. So if you have collected in a similar manner with our data, as you just have seen our database list, there are many cities included in our data set in the first. So we have a couple of different countries and various cities embedded in them. For example, Antalya is one of the Turkish cities, Izmir and Ladise is one of the Greek ones. And we have a couple of images for each city that we have. And our main aim will be to classify these images in terms of their labels and give a complete new image without containing the training set. And we will just discuss how the machine can understand which the photographs are taken from. So in this interface, I'm just creating classes in terms of the cities. So I already prepared one in order to show you guys. So as you can see here, I have a list of classes related to that database. For example, you can see Izmir, Manisa, Haliki, Lesbos, Mykonos, Samos as well. And we manually uploaded the images from Google's Drive folder that we have. As you can see here, it is important that you upload each class equal number of images in order to maintain the model just without any biases. Because if you put a lot more image to one class, it would start to somehow alternate the result in a favor to that class. So you can see here. And here we train our model in using this interface. I can increase the epoch size as it would take much more time, but the results will be improved. The machine starts to learn better the inherent classes within the images. And the batch size is about how does the machine learn to process image. If you increase it, the machine starts to do it more faster, but decreasing is almost are always important to us because we are just using a small set of data. So it is important to understand each scale and each pixel of the data with a smaller batch sizes. And the learning rate is the pace of the machine learning. If you increase it, it will take much more time, but it will increase the results a little bit better. So I will just train my model with using that sample images, as you can see here. It's already trained because I just run it. And I can search for any other architectural image that doesn't contained in my training set, and upload here and see the output from there. So I'm just typing Google for any kind of image that I can use to test my classification model. For example, I'm gonna say Antalya houses, maybe Antalya vernacular houses, much more specified search. For example, this one. Just let me check it if I have it already in my dataset or not. For example, these are the images, and this is not contained in my dataset, so I'm just downloading it. I will just choose the image that I just downloaded from here. This is the data implemented, and it shows, for example, the Larissa. As you can see, the output is not classified correctly because of the insufficient amount of data. If you increase it or you try to give much more similar images to that, the performance would be better. For example, we can say the similar images with the data sets included in the classification method from this one, for example. Let me just check it if I don't have the image in that sense. For example, it is similar, but it's not the same one. So I'm just downloading it. So I'm gonna upload this one. And see the results. Again, if the machine is not trained well with the correct number of data sets, it wouldn't be so meaningful. But if we use already trained data sets, it might give us better results. For example, this one. For example, as it is contained in the data set, it would give the 100% precision. But if we use, for example, not the Antalya this time, but Izmir maybe, because it's contained, I'm choosing a different option then. It is not contained in our data set. I know it is. Maybe this one. Again, the Larissa. It is because our data set includes so much similar images, because our main scope was to implement this model on the Aegean region, which is based on a so similar architectural style, as you can see it right now. This is one image from Izmir again, and maybe this is one image from the Thessalonica. Yeah, so the Aegean architecture features are similar, so does the machine tries to somehow confuse it while training it with a small scale data. If I just upload maybe 500 images to manifest folders to 500 to Izmir, it would start to understand better the relations of the labels and the image set. But we can try that one. And if we just try to divide the data set into the two folders in terms of the Greek data set and the Turkish output data set, I think it's supposed to implement better. So let us try altogether that. So I'm just taking the Greek ones and I'm selecting all of them. And I'm just putting to download the sample, upload the sample. I will follow the same steps for the Turkey. It might take a little time since we're processing a lot of these images, and my computer is just crashing right now because I have too many applications running right now at the background. Okay. Okay. Just look at the first model. Let us train with the 50F of this time. The learning time rate will be the same. And I just start to train my model. And this process doesn't take, hopefully, it's so much time because it uses the Collapse GPUs again. And it's so fast, unbelievably fast by doing in your own computer. It's for the cloud. You can also try with your own webcam and scan your image and try to classify it as a Greek architecture instance or Turkish architecture instance. But right now we will use just like the in terms of the architectural images. So I will again search for a different architectural image that doesn't contain in our data set, for example, this one. I'm downloading it. And I will upload, not this one, not this one first. Okay, this one is from Turkey. Let us see, it's 100%. Maybe this image is also contained in our image data set. So I will search for a city that I didn't put in the data set. So maybe
Safranbolu. Did we have any
Yeah.
Safranbolu?
no, actually we didn't have a jump. So this one maybe. Okay. It matched with the Greece, so the architectural type of it might be similar. That's why it might be ended up with like that. But let us search for another instance. This one maybe. Yeah, this one belongs to Turkey. So, and I'm sure that I haven't included any Safranbolu images in my data set. There are similar images, but this is a classical Turkish traditional house architecture. That's why it implements that correctly. For example, we can try for a Greek version. For example, the Aegean Islands architecture, maybe. We might end up with the pictures of Mykonos or Santorini, but I'm just gonna use this one. Okay, it's 100% Greece. So as you can see, the other trials were a little bit failure in terms of like the image samples were not enough in terms of like the number to pertain the 16 different class of images. But if you just train your model with more image samples, as we can see here, the model precision will get better and better each time. So if you are just clear with it, if you understand the logic of it, if you have any questions, just ask right now. Then we will just like expect from you to like use this tool in order to understand your data better. And maybe you can try even with your generated output. For example, let me try that first. Okay, I'm just excited right now. So I have just downloaded a couple of like image that is the output of our machine learning process. As you can see here, the machine has generated some outputs with using the audio spectrograms with Pix2Pix. And let us see in which country does it refer to. So it says that the generated image is most likely to be in the Greece. For example, let us try that. It's again Greece. This one, again Greece. And this one, again Greece. So the machine, we can say that it's favoring Greece, but like it's about the images, like the pixel ratio. If the resolution of this dataset is lesser than the Turkey dataset, it might be the result of that. But other than that, the machine knows it better, I think. So I can stop sharing right now and answer your potential questions, and I can share the link with you guys. I'm just teachable machine, as you can both see. And here is the link for us. Please go and try to implement your model, and maybe you can share your databases with us in order for us to see which label that you have. And if you don't have enough instances for each class, you might try, as we do, like just separating into 2 or 3 classes. It would be better to machine to pertain more. So don't try to divide your data set into much clusters. It will affect the outcomes, as you can see. But if you just maintain 1 or 2 classes, I think it's supposed to work better. So Lale Hocam or Mustafa, do you want to add something?
Is that almost like a TensorBoard?
What?
Is that almost like a TensorBoard?
Yeah, there's so much like classification models, both like the code-based versions of it. But we have just preferred this one to show you in the workshop because it has like a basic interface for you guys. So you can try it also in your Google Colab account, or let me show that also. So I'm just sharing my screen again. So if you just train your model, you can also download the train model by exporting model. As you can see, it gives different outputs to implement in different kind of coding environments. So this is one belongs to JavaScript. This is one C5.js, which used by the processing, if you're familiar with. Or you can copy the code using the Keras library from the TensorFlow. You can just copy it, and whether you just run locally in your computer using the Python environment, Jupyter Notebook, Visual Studio, or whatever. But I just stick on the Colab, and we have implemented this code on the Colab. And the downloaded model, when you just click up this one, you see the Keras model, you can download it.
Yeah.
And after you download it and implement it into your drive or your local folder, just change the file set to that downloaded model. And from the image that you want to test, you can just copy the path of the image. And when you run it, just let me run again, but I'm not so sure whether my drive is mounted right now. But as you can see here, the previous outcomes were like this. It gives me a number of arrays, which, let me just rerun it. But Just waiting for that. Okay. So you can see here, it doesn't visualize it directly, but it gives you the information in mathematical manner. The numbers here are corresponds to the relatedness rate. I can say it like that. So the E upper part is 0.4 is much more smaller number than the E101. So in this array, we can say that the last index of this array is the most possible prediction. So in that label list that I just downloaded from the Keras library, you can see the labels on it because we just have two couples of moments. It doesn't belong to this model, but this model is trained with 19 labels as in the first example. Let me open this one. Okay, just a minute. Can you see it right now? The labels, TXT file.
Yes.
Okay, so this is the 19th array and starts from 0. It corresponds to Thessaloniki, and let me just check. It is also the Thessaloniki image. It couldn't retrieve it because of the connection issues, but as you can see, it labeled it correctly in the Google Colab interface. But yeah, you can try in both interfaces. If you're just familiar with the Colab, it might enable you to customize code more in order to understand it better, change the batch sizes, etc. But the model is already pre-trained in the interface, or you can just try to use one classification image to estimate the classification algorithms that you can find many on GitHub. Implement that one in terms of like the model, classification model, and then run the code again and open your images and try to see what the machine would say. So did you get answer for your question then?
Yes.
Okay, perfect. So does anyone else have a question by the classification algorithm? Kaan, could you find a chance to follow up this discussion? I'm just calling your name because I know you from IBK as well.
Sure. My voice is coming right now. Oh, okay. Sure. I'm just following all of the steps.
Okay.
Actually, I have one question about this. I want to open my camera first.
Okay.
And this website, we just trained the machine first, and the website is given us a customized model file.
Mm-hmm.
Can we use this custom model file to the different kind of open source algorithms? For
Yeah,
example,
it gives you the classification model basically on Keras when we download it. So you can implement this code in whatever type of like the notebooks that you have in your PNB notebook. It would work, I suppose. I didn't try it yet, but it should work because it gives the direct classification model with labels and the trained algorithm behind that.
okay, that's good to know to this thing, because I don't know how to create the model files that as a quick. So yeah, this is the good for me to.
You can always try the other codes for just generating the model files as we do, for example, in Pix2Pix, but there's a diverse pool right now in the world that you can just easily grab.
And one more step I didn't quite follow. We just collect all of the data with the Octoparse, for example. the old images are just given as a different sizes. So with the collab file, we resize it and rescale it. And but in that part, we just do that, or we
I didn't use the resize or recrop versions of it because I just need to like the one image to be classified. You can try with that also, but it isn't necessary because the reason that we resize it actually for the pixel algorithm, because it needs to have like a square based image and certain pixel number in order to run the model smoothly and in a like quicker time. But since the classification model uses the fast GPUs of Google, it doesn't take so much time, as you can just see in like it's completed in 10 seconds or so. So it doesn't have to be a resized image or a smaller file size in terms of providing the data. You can provide whatever you want.
Okay, that's fine. That's cool, actually.
Okay.
And also, I in that time, meanwhile, I'm using the yesterday file and just try to new audio
Spectrograms.
yes,
Well,
spectrograms.
I was gonna ask that. I saw the generated image. It's not like a perfect result because it reflects so much similarity in terms of like a building facade. For example, it might be. I thought that like Frank Gehry's Louis Vuitton Foundation building,
Yeah.
especially, is that this one? And that does that image have been contained in your training data set?
Yeah, sure.
Yeah.
Actually, my data isn't it the local houses of the Izmir or Greece.
Okay, that's fine. I was asking for, did you test this like the model, is it working correctly, implemented correctly with outside data that you have not implemented in your training model? For example, you can generate the model as we done with Sao with using one of our just audio spectrograms and see the results by that. So you would have much more blurry images, but it would make some more original in terms of image because it didn't train with that data as well. It would be interesting. You might like to try that as well.
Actually, I just think that way, but some of the audio spectrograms are fit the just high quality facade silhouette given to me, and it's how can I say, all of the spectrograms, alternative spectrograms files, and these kind of codes just arrange systematically, and I solved that because some of the spectrograms didn't given some facade or some building silhouettes didn't understandable. But the one of the cases, I just find some spectrum and just implement that, and I have a kind of 10 or 15 results came for me. And all of these, you mentioned about the Frank Gehry's buildings on that part. And I just picked these pictures from that, and high resolution algorithm I use that, and these outputs are very understandable. If it's available, I want to show the
yeah, you can share it.
Because I first time tried this, and it works very and the outputs very understandable for me, and I think it went work great. So first I want to show I copied all of the source file, the last one, notebook file. I'm start work there. And spectrogram name starts with that part. For example, this music, Mayan 3. because we split the audio files at the parts.
Mhm.
This is the third part, and I picked this song from the second part, and you can see there was some quite.
Can you
Awesome.
open this, like the source PNG file, Kaan?
I'm sorry.
Can you open this source file, this spectrogram file? I'm just curious.
Yeah,
Because
sure.
right. You
Actually,
can just click on Control and tap to the path, and it would directly open. And Control and path. Ah, it works in my computer, but okay.
like that? No.
No. It actually has to give you the correct link to. Oh yeah, this one. Okay. Oh, maybe you have just changed the folder, or your drive isn't mounted yet.
Yeah, I think, but I find these files manually because all of the spectrogram images are just listing side by side. Yeah, that's one. For example, this is the Neton. Yes, that one. For example, this the spectrogram name Alga1.
Can you show us the spectrogram?
But this isn't. Yes.
Okay. So that's how the model works actually. So you generated whole spectrum. I was just curious about, because in some cases the input that you have put might be within your pre-trained model set. That's why the model works seems to be well. But in your condition, I think since you just have specified the pairing ship, it works a little bit more precise manner. I think it's a good result that we can say that.
And yeah, I surprised about that. And I find that this scheme, because I find that there was a scheme about that. There was some rule about that, and this file name is Alga1, and Alga1 just creates me a yeah.
But if you just try, let us see the result with the data outside of your training folders. For example, choose one of us as Taudis with spectrograms and train with that. I'm just curious what it would generate with using I suppose your architectural data set contains the constructivist architectures, kind of like a style as a style.
Yeah.
So,
yeah, my models are collected with them.
Okay, you can try with different music data sets now. So explore it one more time. How does machine will create?
You mentioned about the different music data, so I need to
generate with your own idea from taking a song from YouTube and converting into the WAV again and scripting into the different spectrograms and using that spectrogram as the input for the generation. For example, when you load an image, you see that there's in the search path, you give a specific path that is also contained in your data set. But if the model has not been trained with that data set, it will generate totally different output.
Okay, I understand. Yeah, I'm just curious about what's happened about this new WoW music and new spectrum, how creates in that model file.
Yeah.
Yeah, what's the inputs? I'm just curious about that. On that part. And I rescale it, these files to see the much more details or some missing parts. Actually, the algorithm creates some burns or actually the film just 35 millimeter analog film burns. I just mentioned about that marks.
How did you resize it using the same code?
I'm using the super resolution algorithm, ESR GAN, yeah, 4x multiplier
It
algorithm.
might be because of those algorithms usually works with the pixels, RGB colors.
Mhm.
So in order to resize a larger picture, it generates like the average of the neighboring cells and
Mhm,
adds one more. The basic principle is like that. That's why it might valid for your case, the burning issue.
But the output file, the original
Uh-huh.
files have that. For example, this is the original file.
Uh-huh.
And yeah, it's like a sun, but it's a kind of burn, and there's a kind of same issue about that.
I see.
Yeah, I find out these things. For example, the middle of the color is changing, and this one. And after that, of course, the algorithm just resize it and given some much more details, of course.
I see.
Yeah, I want to show all of the results. This is the my favorite one.
Mhm.
And yeah, I'm just working on that part yesterday.
I kind of recognize all the buildings in there.
Yeah.
Okay, well done. Thank you for your contribution. I'm just excited. I will be excited to see the other results that I was talking about this. So
And Khan, are you going to try this app, the Teachable Machine?
Yeah, I start to organize the pictures.
Mhm.
Yeah, I'm gonna try it.
Okay. And hopefully you can share that with us too.
Mhm,
Yeah,
sure.
output. Okay.
I would like to share.
Yeah.
So the other participants, does anyone have any question related to the teachable machine part, the data classification part? So I assume everything was clear enough. I assume that. Okay. Then we maybe give a little break to see the results then, if you would like to.
Yeah, they can work on that and maybe half an hour
Okay.
to see how it went.
Maybe after then we can share our training results.
Yeah, yeah. Mustafa Hocam, what do you say? Is half an hour fine?
Half an hour, maybe. Yeah, it's fine.
Do you think it's short?
No, it's fine.
We will just
We have
show
some.
our already gained model output first.
Yeah,
Then
we have
maybe
some.
then explore this thing also.
We have some good results in
Okay.
generating building images too. So maybe we can just first share them.
Yeah.
Then,
I was talking about that.
Okay.
okay.
Okay, so see you in half an hour, 35 minutes. What? Okay, 24 minutes
Okay.
to be exact. Yeah, see you.
See you. Hi. We are back. So shall we start to see our model in output? Is everyone there? Can one of us just remind me if you're there? Okay, perfect. I'm just gonna revise and wrap everything that we have been done until this point in our workshop in terms of like the workshop IPNV notebook and show the output of it. So, I'm just showing the other part. So we have generated our data set, as we all follow the steps. And at the end, we prepared image folders for our that contains multiple images from different cities. And we have resized them. And this one was our initial data set, as you can see here. It's all cropped down to the square. And it has the specific pixel values, like this one, for the architectural instances. At first, we trained our model by using that. Then we added more data, and I will show you as well the comparison in between while training a smaller data set and a larger data set. What would be the difference in the outcomes? So you can see here, this was the initial data set that we trained. I'm just scrolling a bit. Is all included in the first trial, and the one that is coded with the numbers and an alphabet as the new addition to initial data set. So the initial data set were containing 254 images, and we enlarged it to the 550 images in the second step. So this was the process to converting the MP4 files to MonoWAV format. Then we have to split those WAV files into the parts. Then we convert those WAV files into the spectrogram. So I want to show you as well the output of this process. The spectrograms were like that. It has been resized into the crop, the outer corners that have the white space deleted. And our pix-to-pix algorithm was trained by using two data sets, the spectrograms and the architectural instances, as we all know. Then this is a little bit just for the converting MonoWAV files to spectrogram again. Then WAV to TIFF for different kind of spectrograms, but we initially used the colored ones because it contains much more information than the black-white. And again, converting spectrograms and resizing again the parent images inside of like the main collab code to be the both spectrograms and the resized images would be share the same attribute. Then we have paired those architecture images with spectrograms randomly. Each list in the data set in terms of their indexes 0 to 0, 0, 1 to 1, kind of like a batch process like that with using that style of the code. And we have generated a NumPy array list as NPZ files. I'm not so sure why it goes upwards when I just showing it wrong, but you can see this was the NumPy array file. So we take that load data from that using that file. So this was our plotted image in terms of the pairs. Then we start to develop the pix-to-pix model. We have imported libraries from using the Keras. Then we have defined this discriminator in order for us to tell which images were close to real, which one was the fake, and we have plotted the loss outcomes, defined the generators. Those have like the encoder blocks, which are the convolutional layers inside our model. We have combined them, Then we load the images as arrays, NumPy arrays. Then we started to train the model. After that, we have just the process completed in, as I remember, 2.5 hours for the first data set. And we started to translate the images, plot the sources, generate the targets, and see that our model has been implemented correctly, that when we give the source file as the input, and the expected outcome would be the paired image that we take upon. And the generated image, as you can see here, shows a correspondence that we can say the model works well. Then we tend to translate new spectrograms into the file, which the spectrograms were not included in our training set. So we can say that those images are the instances that the machine completely generates, that have no attribute to be like labeled to any kind of an architectural building in the real world right now, but the generation of a machine output from the spectrogram file. Let me show that. So currently, I'm not connected into any runtime, but this audio file was converted from a different song that's contained in our data set. So it's a completely new image. So let me briefly show you the outputs of our machine learning process. Sorry. So the initial training results with using only the first 250 images that are labeled in terms of the cities, districts, and the countries were like that. The training outputs were like that. This is the model of the first epoch. So the model have been increased its capabilities in terms of generating while training it much more time with different epoch values. So as you can follow up here, the plot 67 to 80 shows like the image correspondence like that. Whereas when it increases, you can see the features, architectural features are coming on with the spectrogram. And those are the evaluation of the model. Evolution, not evolution. Okay, step by step, it started to implement much more architectural features. Like that. So this was containing 250 images, that is as I said before. And when we have trained our model, that's by adding much more data into that image data set, we started to have a complicated result. I will briefly discuss what would be the main reason behind that. But this is the first epoch, so we were expecting to have some blurry images. And the later step, it gains much more information, and it turns out to be more precise images in terms of pixels, as you can see. Oops. Like that. Maybe I can just switch on to the latest result, the final output of the machine. So as you can see here, the data sets have been trained with much more larger data sets, gives much more precise images. But in terms of the resolution quality, it can be said that it has been declined. Because the reason behind that might be we think that the other images that we just extra put on have a lower resolution in comparison to the first instances as this one. As you can see, this is a much more higher quality image, whereas the other ones are a little bit more blurred images. So it might be the reason why that we haven't been able to increase our model generation capability so much. We say so if we just train our model with higher resolution image and increase the amount of data in our data set, the machine would provide better results as we develop the model. Oh, it is like that. I'm gonna ask Mustafa if you have just provided any new spectrogram files to test it out.
Yeah, okay. I will just share my screen with you
Okay.
to show some newly generated building images and then some spectrogram tested. So, here we go. Okay, you can see it, right?
We can see it.
Now,
But can you just like larger the screen? Because I just
okay.
see as a square, if it's possible.
Much better?
Yeah, better.
Okay. So, we just run it with the, as Sezen explained, with our Aegean architectural images and Aegean folklore sounds. And then after some trainings, we did try with some new spectrograms that does not included in our training set. And here's some interesting results we have. Like maybe you can tell something about the image quality and this as well. I think these are much more like a building. At least the outline of the building is now very clear. I think at least at this one, and these are the windows and etc. As you can see, we have some advanced, some better results with new spectrogram files, and we can say that the outline of the buildings and the windows and features of buildings becomes more clear with those things. And also we just tried to generate new music files from architecture, and for that you can try that too. For that you just need to change, you can't use the new same training set, but while loading your images you just need to change this part, the source list and target list, just differently. At the original one, this was the spec images and this was the arch images, so that our input will be spectrogram and the target will be arch images. To reverse the process, we just did that input as an architectural images and the target will be spectrogram images. So the rest is the same. You just run it again, and this image will become like this: the input and target, input and target, input and target. You don't have to change anything at the model. You just change. You might want to change the save location of your training results. And of course, this one here, sorry, I'll just explain it too. So while you are loading your images, when you change this source and target list images, you might want to change the name of the zip file, this MPZ file, so that it doesn't replace your original file. After that, you just need to change all the MPZ files to the name you gave it here, original. So after we run this trained with architectural images to create spectrogram images, the results will be like that. The source was this, and generated image and expected image. And if you just run it again, you can just randomly select another one. Yeah, like that. Source, generated, expected images, and we just run it with this test images. It does not include it in our training set. We just run it with this image to create this spectrogram here, and there's been some error in my Colab, so I couldn't. I will just show you how to convert this to WOW file here, but I just did it on my local computer, not on Colab. There's just some, I don't understand, some problem in my Colab. This one, yeah, okay. So I will just change my new share, okay, and want you to see this one. Okay, you can see all my screen, right?
Yes, we can see it.
Okay, no. Just the same code here in the Colab. This code is in the Colab too, and this creates this test WOW here, and I don't know if you can hear it, but I will just. Can you hear it?
I couldn't hear it.
Okay, now share computer sound. Okay, now maybe you can hear it.
It's kind of like a sci-fi soundtrack,
Maybe we
but
can, there's some noise, of course. It's because just the
Yes.
mono WAV file thing, single channel thing. But I will show how it converts the original ones here to.
I'm just so like surprised with the outcomes. I'm proud of it.
And this will be test. No, okay, no, we can try this again, and this one not other side there, this one just the new sound.
The machine as a musician.
So that's very exciting.
And I will just show you how to how these converting the original sound, original spectrograms to original sounds again, so that you can see the difference between them. But there's some noise in it, of course, but I'll just show you the original sounding too. This one, like 1, 4, okay. This is the original sound. Okay, you get the point. Now, this changes. When did you write it? doesn't want. I don't understand. Here it is. So the noise is common when creating from spectrogram file. It is there, but this one here is maybe we can work on that to filter the noise and create the original sound. Maybe, but
We can further imply a noise reduction
Yeah,
algorithm on top
yeah.
of that, yeah, basically. But I think it's the initial outcomes is like fascinating.
yeah, I mean, it just
We were not expecting like an album or like a single file, so
Yeah, we're listening to architecture.
machine generated architectural music.
So I don't know if our participants are also excited. This is an experimentation, as we announced earlier, and we wanted to share how we did this experimentation, and the results are as new to us as it might be to you. So if you have comments, we can hear.
Yeah.
I have a comment about that. It's very excited actually, and the first time I listened and I was shocked. And oh, it can be converted. If it can be converted, it's what sounds like. And yeah, it's very deep and very inspireful thing to do. And there was some keywords about the architecture and music, and yeah, this sounds like very how can I say? Yeah, it sounds like very inspireful, and yeah, it's exciting about that. And can we do this about our outputs? This
Yeah.
yeah, you can. I will just show that. You can still my screen, right?
Mhm.
So in this converting mono WAV files to spectrogram part, there's this commented part here. If you just uncomment it, you just need to give your image file here, spectrogram file here,
Mhm.
and rest will be done. And this is the name of your desired outcome. You can just change it, but it will just create the WAV file and save it.
Before we just created the WAV file with separately, so these files should be work, I guess, right?
Your files, right?
Yeah.
Yeah. It
Before
should
the,
work. If you
we
just
create the
give
datasets?
gave them here, if you just gave them here one by one, it will create the sounds from the spectrogram images. Okay.
Okay, thank you. I'm just started working on that part.
I'm excited about the Frank Gehry's musical architecture.
Yeah, yeah, actually. And yes.
So you also can experiment on I'm not so sure whether what the data set was included the Chinese architecture or what, but it would be interesting too.
What I'm interested in is about the blind people,
Yeah.
some disabled. They are more sensitive to abandoned sound, the sound around the sound in the environment around them. And I think some space can transform by machine learning to interact. the experience is to investigate to configure maybe some like a GPS stuff for each person, for blind people, and record the audio data
Mhm.
at that site using GIS data. And while the pictures of buildings or street scenes, the street capture,
Mhm.
at that address will be captured by us. We can capture the picture and they can give us the audience data, what they can from their sensitive, their feelings.
So we can easily, after that step, generate a Google Maps of like the soundtracks of the city.
Yeah,
So if
and
we put,
yeah, and this code can transform the architecture to the music, and
yeah,
we can give the music to them, to show the music, to show the sound, and get some suggestion from these people.
it will inspire the designers and architects, especially in the early designing stage, in the concept period, to inspire from the music as well. And also, like it's as you just mentioned, for the disabled people, it will just visualizes somehow, not visualizes, but audioizes the architecture around us.
Yes.
And various aspects I found this like valuable, but I'm not so telling that I'm mesmerized right now, but I'm so excited just because of that.
Yeah, the hearing the music of architecture as an experience in the city is also very exciting, as Tao said. Yeah, this experimentation can branch into several paths, and if you are excited about this, we are a research team, and we're going to be going on with this research and where it takes us to. And we have some questions about, as I said earlier, about the tacit side, the implicit knowledge of architecture and music. And this is a very interesting domain to explore. So having people from different parts of the world and Turkey will add a lot to this research. So if you share our excitement, you can always join us.
Yes. Yeah. Okay.
Mhm. So do you want to try? I mean, Kaan, you asked how you can change Mustafa Hoca just showed
Sure.
it. Do you want to try that?
Sure,
Or
I want to try
okay.
that, but right now I'm just working on the previous
Huh.
the output files. I can show it, of course. It
Okay.
didn't finish it, but my collab is working right now. Some another algorithm just working on that part. It didn't finish, but I can show you. In this workshop, and this Frank Gehry's building types, the one of the yeah, now it's sharing. So right now I'm working on that. I just picked one of these output spectrogram images. I just pick. How can I show? Yeah, this Walt Disney concert hall actually. I pick this image.
Mhm.
And as I show you, I just increase the resolution in that type. And I use the, nowadays I'm working on the Disco Diffusion, and I just use this image, the step-by-step and process is the text to image. Yeah, there's a props on there. This algorithm works with the text to image, is like that. And I just say it's the Frank Gehry's stuffs and some fantastic and some futuristic architectural styles and the steel things. And I just add the cyberpunk and just future relative stuffs on that part. And I just write down the Gustav Eiffel and the Antonio Gaudi, for example. And I choose the painting style. And yeah, I turn this thing to this thing right now. And yeah, I want to show this image in that period. Actually, it's quite artistic, and yeah, some lots of details happens on there. And then it's finished. I'm just working on this, the audio file exporting. I think it's located on there. Yes. Yeah, as I said, now that file is finished, I'm just skip this part. But I want to show the this algorithm and this workshop outputs to another AI algorithm, and yeah, I want to show this. Maybe I can open. There. Yeah. As you can see, there's some robot cyber punk feature based things, and some of the still details. And there was a picture on that spectrum output to another algorithm we use.
How different algorithms would work then, like the text to image, audio to image. There are so much more things to explore, I think, in the machine learning environment.
No
But
problem.
it's exciting. It's just like the resolutions are quite high that we have in our workshop, but I think it's because of the Disco Diffusion uses the big data source to drive the all instances.
Yeah.
That might be the case. So they have a lot more data than we have.
Sure.
Yeah, it's perfect.
Approximately 150 gigabytes model data I use right now. And there was, of course, this model data is the all of the museums, the bunch of museum arts, yeah, pictures and some sculptures and the photographs, all of these artistic things. And this is the very advanced algorithm they use. And yeah, the step-by-step it's generating right now. This is not the final step. Yeah, this is not the final step I showed you. I don't know why I can't show all of these, but yeah, probably it's finished in the 5 minutes.
Do you know, Kaan, which database that the Disco Diffusion uses? All the data available in the Google Image dataset or some open source data? Do you have any idea?
Actually, model data names the clip files.
Clip clip set image set. Okay.
Yeah, the clip files are right there, but I didn't include all of them because my CPU didn't
Allow.
have any memory about that. So
Okay.
yeah, this is the basic clip settings.
For inform the all participants, we have seen this clip data set in the first day when I was introducing you to the open source algorithms.
Mhm.
By the presentation, you can also just click to that.
Yes. And yeah, I think this is the final step.
It's wonderful.
And after that, yeah, I just resize this image and add some Photoshop features on that part. And yeah, this is the very unique piece of conceptual architectural art, as we can say, or just a sketchal render, maybe we can say. So yeah, this is very inspireful to me. And yeah, and then that finished, I can share the audio file came from the my data set, of course.
Okay,
Yeah,
very
I'm looking
nice.
forward to hearing the music of this
Mhm.
this image. That's very interesting.
Is there anyone else that wants to share their process with us? Or everyone is trying, I guess, to converting the images to the music right now.
I have some suggestions about how we can use the audience and the pixel to pixels from the facade, not just of the facade. We can change the audience to the plan, the follow plan. We can give the follow plans some changes, and we can lay out them like 3D printings and loft the shape.
I'm not so sure that I understand. You were talking about implementing the floor plans on to 3D printing in terms of like the special qualities to see that, or
I mean, we can
Image data.
analyze not the facade. We can analyze the plan.
plan? Yeah,
Yeah,
okay. I see.
and one plan
It might be
by
that like
layers.
that. Yeah,
Yeah,
it might be interesting. Yeah.
Initially, we followed this path since that was the most accessible, the pictures of these local architecture. But using the floor plan images, like Chilo has used, will be very interesting. But right now we have, I think, limited data on that for vernacular architecture. There's less variety, I guess, in that. That's also how we're thinking of expanding upon this this knowledge. And that will be, again, I'm saying, very interesting if we can collaborate with different parts of the world, as well as the country, of course, to get a variety of different, maybe we're gonna just, in the end, maybe we're gonna just uncover something very interesting about the humans, right? The way they create their space. So that will be very exciting to analyze them. And yes, floor plans are also very interesting. And in terms of 3D printing, are you saying that that can turn into like like a music file, it can turn into an STL file, and it can go into and get 3D printed. You mean that?
Let me show my screen. Maybe I did some try
Okay.
before last year.
Okay.
Can you see my screen? Because I did some try like follow plan user style again transform. And this is a style to they use PyTorch. I think we can add the music to each follow plan and generate the animations, and we can get each frame of the pictures of the image, and we can get these pictures and recognize the point clouds layer by layers. Like Photoshop, it's all like it's like the channels of RGBs. We can recognize points, clouds, and layer by layers, and finally we can get the layout out to the top, up and up, and we can get the meshes from the point cloud, and finally get our buildings. But it's using Grasshopper from point cloud to the meshes, and I think the music maybe would be different results, but actually we can't get some more focus about music and architectures to get the result layer by layers using 3D printings from the image to point clouds.
So generation tool would be the music that time, and we will just generate the 3D within those, like the in between those layers in terms of floor plans. And
Yes.
okay. I kind of understand that one.
I missed this part on the right. And how did you get that?
I use the Grasshopper. When we have we can generate the animations, or we can get each frames. We can get each frames, and each frames we can recognize the point cloud by Grasshopper.
Okay, so this happens in Grasshopper, but yeah, the next one, the black and white one.
This one?
Yeah, what's that image?
This is all the point cloud layout.
Huh.
It's
okay, that's the layout. Mhm.
Yeah, it's like a front view of the building, and this one is the bounding errors of each point cloud can generate like this. This one is one piece of this one, like this one.
Mhm.
And after that, we can use using this point cloud to generate the meshes. By using Grasshopper.
Yeah, that's very exciting.
Yeah. So we will just first produce the floor plans using the audio spectrogram. Then we convert this machine generated floor plans into the point cloud. Then we extrude these meshes to generate a 3D building plan, right?
It's almost like the what kind of the English name it is? It's named let me see. It's named the Cocoon.
Cocoon Tower? I don't know.
Mm.
Okay.
Because you can see this is the meshes, but actually they are point clouds
Yeah.
within different distance. This is 1 point. This is 1 point. 1 point. So we can, based on this point cloud, we can generate the meshes in this way, just
Mm.
like this. Yeah, like this picture. It's much more clear.
Topological mesh. You were
Yeah.
talking about them. Yeah. Okay.
Yes. So we can based on the point cloud generate the space.
I see.
And Tao, do you have work like this that you want to share here?
Yeah, but it's maybe take a long time. Let me see how can I do this one? In Grasshopper, let me see. Can I show it tomorrow? Because it's quite a large file. It's almost 1 year. I haven't touched it.
Okay, okay.
Okay,
Yeah,
I
all the
just
don't-
files
wanted-
here. Yeah.
Yeah, I mean, the workshop ends today, but I just thought you may want to share it. You don't have to, but it would be nice to see your work here too.
You can put it on the Discord. It would be available for both of us, and we may just see it and comment to them for the future studies. But I'm so also like excited to see it.
Yeah.
Mhm.
Yes. Here was the code. Last year I used the wrong way. Generates these kind of images, but this year I learned more about Colab. So Colab is quite freedom than Runway. Like the music this year. Yeah. Some simple ways Grasshopper can do is we can extrude the image to 2.5D dimensions. And after that, I thinking about the point cloud. We can generate point cloud based on this kind of images. We can detach the point cloud into different teams, like the white one and the red one. The red one is about this kind of RGB colors, this range, and this one is black. We can recognize them using Grasshopper. So we can get the point cloud what we want, and just generate the point cloud layer by layer, and using this one. It's not very. I'm not sure is that clear for you.
I see. I think that I understand what you mean, but yeah.
Yeah. So I suggest I think maybe let AI talking about the follow plan is something where we can generate the 3D shapes. Yeah. because if it's based on the facade, facade is also can,
Yeah.
but in
Facade,
some
maybe the
ways, yeah,
sections,
yes,
maybe like that would be the layers for it. Different
yes,
sections of different and the same building. It
yeah,
might work also like that, but the floor plans, I think it's more available data than the section for each building.
yes. Maybe I need to I don't know this one. Let me see. I'm not sure. Yeah, this is something I recorded last year. If it's based on the facade, we can generate point clouds from the facade. And we can also generate point cloud in this side, and this side. We can make the Boolean in the center. Make the Boolean point cloud in the center and generate the meshes. And this is something I tried last year. So or maybe I can explain more than like Grasshopper tomorrow, because it's I moved this document from another document patch. So maybe something was me to
Interesting.
you need to modify the code, and I can show.
Okay, I see. If
Yes.
you would like to share with us, we would be happy, but if you're so
Yeah. And just
okay.
to
Thank
try.
you.
Yeah.
Okay,
Okay.
thank you so much.
Cheers.
Thank you very much. Very much. Any kind of decoding is very important in this stuff, because the machine picks up the patterns way better than us. But the way we learn is also through patterns. So that's why it's very interesting to see. And the stuff you shared is very inspiring for us too. Thank you.
My pleasure.
So anyone who wants to ask or share anything? Among the participants? Any one of you that we don't know that they're working on this stuff, and they need time and they want to ask anything? This is the last day of our workshop, and we're going to keep in touch. But if any of you would like to, let's say, work on on either the classification or transformation to music from architecture, you can still have some time to work on it and ask questions. And we can end it we can give a break, and hocalarım maybe 1:30 we can come back and help out with the questions if there are any.
Okay.
Is it fine for you? Like half an hour?
That's good for me, but I'm not so sure. Mustafa answers. açtık, I think.
No, it worked for me.
Okay, so let's give a break, like half an hour. And yes, when we come back, we can talk about the challenges you had, if you have any. And then say goodbye. Yeah, meet in half an hour.
See you.
Hello. So
Hello.
let's see. Kaan, Tao.
Yes.
Hello.
Okay, I think Kaan is here. And you want to share your stuff?
Sure. Actually, I didn't manage to create the sound file. I'm just working on it still.
Do you need help with the code or
Actually,
taking time?
I'm sorry to interrupt you. The Collab account is needs to be renewed because I don't have any.
Are you exceeded? the-
Yeah, exceeded the CPU time thing. So
But you don't have to train the model all over again.
no, but same account. I just doing the another algorithm things.
I
So
see, I see.
exceed the all of the accounts the time thing. So I'm working on that another account on that part. But I can show the end of the results of the image I showed. Actually, I posted on the Discord, our Discord text.
You mean
Channel.
you already did?
Yeah, I already did the conceptual
Oh,
art. Just
I didn't see it.
I'm sure I can.
The
show.
ones that you have in the previous session, right? Yeah.
Yeah. Yeah, this is the final result, and I want to mention about the details on that part. And this is the robot. And yeah. Yeah, this is the output of our workshop image, and to resize it and rescale it with the AI. And after that, this image turned with another thing.
Were you able to try that with a new music data?
I'm just trying it still.
Okay.
Actually, my plan to convert this. I just forget to pronounce it. The spectrogram. This spectrogram to music data. I want to try this. So yeah, I'm just working on that part. If I finished and it's ready, I want to show it, of course.
Okay.
That's
Thank
all
you.
for now. Thank you.
And Tao,
Yes.
were you gonna share something?
Let me see.
Mm.
Let's see. Let's hold on. I just rerun the Colab and I change my the real image. And it's running now, and but the results not appear now. Mm.
Can I ask a question?
Sure, please.
Um, the the sound file I need, but the spectrogram, it needs to be resized, or it's completely unnecessary to use the high resolution spectrogram file, or I need to resize it.
For
Because-
the creating the WAV file.
yeah, for the creating the raw file.
You can it works better with the resize part, in the notebook that I will just open it. Okay, I don't remember the sizes.
Because I have only resized one. I don't know why the rest of the original ones is deleted.
But I think that doesn't matter, because we use the resized one too, like the square ones. So we resize it again to that. What was that? Are you saying the
Spectrogram PNGs.
512 to 512
Yeah.
resizing?
Uh-huh.
No, it was just for saving the spectrogram file.
Hmm.
So it was for saving the image. For converting it, you don't need to resize it to 512 to 512. You can both try with your spectrogram file, but I think it works better with. There was this thing,
Original.
the original size,
Mhm.
but the original size was different from any of them. So I
Yeah.
will find it. Oh, yeah, okay. The original size is there. So when you're converting your spectrogram image to the sound, you can try them both with commenting the resize original size part, and try with the original file in your hand. But after that, you can try the resizing it to original size and doing the conversion. I think the results will be different.
Yeah, I think it's different, but I want to convert the same WAV file without the resized, or is the resized one as well. I just want to see any differences of the
So
quantity.
okay, you can comment out the resizing parts and just continue with the original files you have.
And I have some issue with the code thing at there.
No, unexpected indent. So
Just delete the comment.
you need to comment that part from TIFF to WoW. It's a comment. It just
It's a comment.
it's explaining the what code doing, and so can you run it? I think it will again. Yeah. So in the first space on the yeah, you can delete it too.
I'm sorry.
You delete the space. Yeah, okay. Now it will not give you an error.
Okay, that's. I think. Yeah, I think it's. Yes, I don't have any file right now because I didn't connect the drive. So, okay, thank you, teacher.
Okay.
Yeah, I also faced another problem. I'm gonna share my screen.
What does it say? Oh, okay. So can you go up?
Oh, TIFF the wall. My
No, not tilt the wall. It doesn't matter. It just converts it again. But I don't know what does. It's a different problem. Okay, so maybe we can just do.
yeah, same. File paths are same.
Yeah.
Maybe the name is very have a different elements on them.
I don't know. It just run everything. Okay, so can you just comment out the upper side? Just remain from TIFF to WoW part is remained and
All of
no,
these-
not libraries.
This one.
I think we can just open a new code cell from up. There's plus code and plus yeah.
Mhm.
Yeah, so now we just need to original size is not defined, I think. So
Oh, this
no, just libraries from PIL and import Librosa Turbo. Just from the down cell, you just need to copy the libraries to import Librosa, import. There's this part, yeah.
this part too, this part.
No, just the lines from PIL import image, import numpy as np, import sound file. This part. Just the lines, just import sound file. That line.
That line, okay.
Yeah. This is also there, so you just need to. No, not there.
Not there.
You the same.
But I think the pill library is not
PIL
established
library
yet.
and the Librosa library. You need those.
At the top of the other cell. Just go.
Oh,
Not, yeah,
from-
no, don't
from-
too much.
You can see the
Mhm.
from PIL import image line.
This one.
Just the line.
Just the line. The from and
From PIL import
import.
image.
Single line.
Okay.
That line. Yeah,
This one,
that
yeah.
line. Okay.
Okay. Sorry for that. I have a two screen and
Okay.
I'm confused sometimes. What?
On top of it, just anywhere.
Okay.
Okay, so again,
I actually
yeah,
there was a problem on that part, but
yeah, you can comment that out. You can comment.
come on. Okay.
Okay.
I think it's working right now.
It's working, but in Colab, this conversion part takes a little longer.
Huh. Yeah, sure. Because of the cloud system.
Yeah, in Colab it takes longer. In local computer it takes like seconds, but in Colab I don't know how much. Okay, now we have to define SR. SR was okay. I will just tell you. These were normally defined automatically in the other cell, but here we are trying to run it from 0, so we have to define SR and etc. So sampling rate actually SR means, and
Actually, there is a SR.
so wait, yes.
Maybe I can copy this rest of them and try again. Yeah, SR thing again.
I'll just tell you. Okay. So SR is like 22,050. No, not take from that. Just go there and yeah, just write SR equals to 22,000. No, equals. Yeah. 22,050.
Like that or
No, 50.
50? Okay.
No, there's 1 0 is, yeah, deleted. Delete. Now delete 2 0. Okay. And I don't know how much it will take. Okay, cool.
So
it-
the file is right there, I think.
No, it doesn't. Just open the notebook again. From the left side, from folder side, go just down. And it should have said. So okay, let's do it again, but we just add the file location to the test wow on the front of the test wow part.
Okay, we add the file location right now.
No, just yeah, there, the file location, and where do you want to save it?
Workshop.
Okay,
2092.
so copy that. Just paste it right behind the test wall. Just right behind the test wall. Yeah, or the inside the bracelets. No. Just do it the same thing. Just delete the bracelet between them and the comma. No, don't delete it.
No.
just the bracelets between test wow and workshop 2022 and the comma. Just delete the between.
Müsait değil. Tamam. Actually, yeah. There.
No, inside the bracelet. Just paste the paste. Huh, yeah.
And
No. Just right behind the test wall.
there. No.
No. Yeah. Okay. So let's see. I'll just write.
Okay, thank you. and write it on where?
I'll just write it from the chat.
Chat, okay.
Okay, just
It's like that, right?
yeah.
Okay, I get it right now. Okay. So okay.
So let's see. And in case of you want to try it with the original size was and okay, just say. Can you open the test WoW from your drive folder? Yeah,
Yes. You can hear? Everyone hear it? I actually hear
No.
it. Maybe I need to share my voice, computer voice too.
Yeah, computer.
How can I do that? Sesi paylaş, okay. Now, yeah.
Yeah.
It's like a machine.
So can you try it with the resizing to the original size? I just pasted to chat.
So this is the low quality voice we hear, right? Or what's the change it if I turn up the original sizes?
It changes the pixel size, and when you just resize it to the original size, you just like increase the length of the image, so that increase the spectrograms differences between the pixels, and it reads more clearly. So okay, and
I read it down.
no, up just up of the resize part, and just uncommented again. Yeah. Okay. Now we can try again. I think this will take much longer because now the image size is much bigger. What is the original of the sound?
I'm sorry?
The original of
I'm
the
sorry,
sound.
I didn't hear very well.
What is the original of the sound?
Of course, I can find it. Actually, this is the alternative oriental thing.
Okay.
It's the new genre. Yeah. So this is the third part of the sound. we just separate the sound with the 1 minute length.
30 seconds actually.
30 seconds.
A minute and a half.
So, yeah.
Okay.
Yeah, actually, it's a machine sound too. It's like an instrumental.
There's resemblance. But
I can't write it for fun. Yeah, I'm listening.
this will take much longer because the increased image size. But when you train the spectrogram and architectural images in reverse version, like us, when you create the original spectrogram file, we would like to hear that.
Yeah, sure, I want to do that, but I just skipped this part. For example, I want to convert this image to, first of all, spectrogram. How can I do that? I just missed that part.
Okay, so I just share my screen and
Okay.
show it. Okay, I'll show it again. This one. Okay, you can see it, right?
Yeah, sure. I'm seeing now.
Okay, so you just need to change a little bit different to code. When you're loading the images, you will work with the same pairing things. But when you're just loading the images, you just need to change the source list and target list. This is so our spectrogram images are like the first 1256 pixels. So our source list is not actually normally this code is like this.
Spec
And arch. Yeah.
Arch.
So when you change them, your input becomes architectural image and output becomes spectrogram images. So when you run it again, your new model just works with the architectural images to generate spectrogram images.
Okay, I got it. Yeah, I'm at the loading images part, but the loading images isn't a data we collect from the internet right now. I'm just select the this pictures with the final pictures came from the spectrum.
No, you don't have to run with them. So at the initially you just paired some Gary architectures and spectrogram images, right? So we just need to reverse the pairing. So when we change the source list and target list lines, we just say that the algorithm to take architectural images as input and generate spectrogram images. So just change these two lines and run the training again, run the model again. And when the training is finished, your model now generates spectrogram images.
So there was a train. We need to wait, right?
Yeah, you have to train it again. And also change this part too, so that it doesn't delete your initial
sure.
MPZ file.
I changed it. I just create the alternative name.
Okay. And you have to change it here, and you maybe want to change this folder too, to save the new model to somewhere else. You just need to change this one too. And you
after
just need
that,
to change, you just need to change
mhm, mhm.
and change this one too. And this is this will become your new architectural image you want to turn to the spectrogram.
Oh, okay, okay, I get it right now. But this image needs to be our output at the final. I showed the I just turned with the high scaled thing I picked up.
The spectrogram file you
Yeah.
just generated.
Yeah, but I need to import the architectural file. So this architectural file is can be anything else, or I just turn with the resizing and rescale it.
Yeah.
File.
Yeah.
Just
You,
anything.
you don't have to resize this image too again. So
Mhm,
you can try with this. Your test image is this one, your new image. You just want to generate spectrogram from this source image here. So this is not your in your training set or etc. This is a whole new image. So
Whole new
you
image.
don't have to resize it. You can resize it, of course, but you don't have to resize it too. It will take and just convert it to a spectrogram file.
Okay, and after that, I just pick this. That's
Just download the spectrogram and just run the code above again.
Okay,
It is still running, right?
it's still running. Yeah,
Yeah.
this takes very long right now. The
Yeah.
original one.
This is some bug in Colab. It takes so much longer.
Mhm. Now I'm just paused it because the code has worked. We believe maybe
Okay.
it needs to be fast. Maybe I just delete the original file size.
Okay.
There.
Or maybe just lower the sizes.
Yeah,
Like,
maybe. Yeah.
Divide it in half, maybe.
Okay. Okay. I try this. Thank you. Thank you, teacher.
Okay.
Okay, so we came to the end of our workshop. Thank you all very much for attending. And as we said earlier, this is an experimentation and an ongoing research, and we don't know where it might lead us, but definitely it's going to be very exciting and interesting. So we have many more of you in the Discord channel, and we're going to keep in touch. And if you have anything to share, contribute, or ask, you can reach us from there. And the lab is called Archirobi Lab. You can find us at archirobi@gmail.com. But I guess the best way is will be the Discord channel. Yes, thank you. And Selen Hocam, Mustafa Hocam, anything you want to say as a goodbye?
I want to thank everybody for their contribution to our process. As Lale just mentioned, you're at the beginning of a huge project. So this is our baby step basically, but I'm excited to see the outcomes of it. To publish some papers, like present in the congresses. So we would be happy to collaborate with you too in order to introduce ourselves much more wider geographies than just to be contained in Turkey or so on. So I'm so happy to be a part of this workshop. Thank you for Lale Hocam and Mustafa for all your contribution as well. So that's all the things that I want to say.
Yeah, I just want to thank everybody again for participation and trials that they have done and the accomplishment they have achieved. There was some good jobs in here. I also want to thank Lale Hocam and Sevil Hocam again.
Yes, and Tao says thank you all from the chat. Okay, hope to see you again.
See you.
See
Yeah,
you.
Thank you.
bye.
See you. Thank you.